Hey guys, today we're going to talk about ratio tables from lesson 1-4. Ratio tables. And today's date is going to be 10/26/18. Okay, but before I can tell you about ratio tables, I got to tell you about my mom. My mom had this punch recipe, and we call it Mom's Famous Punch Recipe. Mom's Famous Punch Recipe. Now, what makes my mom's recipe so famous is that it has so much versatility. So I'm going to share with you the recipe, and then I'm going to talk to you about what happens if I have more than just the family that needs to get served. So let's say we're going to have kind of just a family get-together, and so we would be making one batch of the punch. Now, the cool thing is it's very open-ended, this recipe. So, for example, I need 1 container of soda. Now, what kind of soda do I use? Kind of what I feel like. Usually Mom always used the clear kind of sodas like Sprite or Squirt or, lemony lime things, or I'm trying to think what else, ginger ale. Okay, so she would pick a soda. And we would need 1 container of soda. But then, to add to that, we would need 3 containers of juice. Now, what juice would we use? Whatever we wanted to use. That's the beauty behind her recipe. So we could use pineapple juice, we could do cranberry juice, we could use grand raspberry, grape juice, whatever it was that we wanted. And we'd take 3 containers of those. So I wanted to form a ratio of the soda to the juice. So we have soda to juice. And that would equal 1 container of soda. Oops, I think I did that. Didn't get my line big enough here. Let's try that again. We're going to get 1 container of soda, and we are going to get 3 containers of juice. Okay? Now, what we're going to do, doesn't matter how many batches of this I decide to make, we're going to end up keeping the ratio of soda to juice the same. Okay? So let's see what happens when we have some family come to visit us. Okay? So we have my niece and her husband and their 5 kids. So we're going to make 2 batches of the Mom's Famous Punch Recipe. So that means we're going to end up getting 2 containers of soda. So let me get that guy in there. We have 2, oh, hello, that's not what I wanted. We have 2 sodas. And for each soda, we're going to have 3 juices. So there's 3 for that soda and 3 for that soda. So when I look at the ratio of soda to juice, I end up having 2 sodas and a total of 6 juices. Oops, that's a weird color. Let's try that one again. Dink, dink. Now, if I simplified, you can see that I could divide top and bottom by 2. And lo and behold, I would end up with 2 divided by 2 is 1, and 6 divided by 2 is 3. So I have exactly the same ratio of juice. I just doubled everything. But then my nephew and his wife and their 6 kids decided to show up. And man, these kids love their juice. So guess what? We need 3 batches. Good thing this recipe's so simple. So we end up getting 3 containers of soda. And for each container of soda, we're going to have 3 containers of juice. And again, we can do all sorts of combination. You guys ever had that, what's it called? Cactus cooler. Kind of an orangey drink. That's really good with pineapple juice. Just saying. Okay? So then when we look at soda to juice ratio, we have 3 bottles of soda, and we have 3, 6, 9 bottles of juice. But guess what? If I simplify this down, they both have a 3 in common. Guess what I end up with? That's right. 1 soda to 3 juices. So regardless of how I did this, it always simplified down to the same amount. Now, that's not anything too surprising. So I found that 1/3 was the same as 2/6 was the same as 3 9s. So when I have ratios that always reduce down to the same amount, those ratios are called equivalent ratios. So equivalent ratios. Remember, equal, valent, value, equal value ratio. So these ratios all have the same value. So we say ratios that simplify to equal the same value. Now, I can already hear what you're thinking. Rosner, aren't we supposed to be talking about ratio tables and you're talking about punch? Number 1, I'm thirsty. Number 2, what's this have to do with tables? Well, hold on. I'll get you there. Okay? So equivalent ratios are ratios that simplify to equal the same ratio. So what we can do is we can organize this information in a table. Ding, 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 ding. There's your ratio table. So on the next page, let's talk about that. We're going to go ahead and organize sets of data. We had 3 in that particular case. Organize sets of data into a table. Okay, that is going to be your ratio table. Okay, so what's going to be interesting about this ratio table is that all of the ratios in the table have exactly the same value when you simplify them. So ratio table is simply a table where all of the columns have the same ratio. Now, again, they may not look like it, but when you simplify them, they all reduce to the exact same ratio. Okay, so what I'm going to do is create a table of the information from my mom's famous punch recipe. So the 2 ingredients were soda and juice. Okay, now the first batch that we made 1 container of soda and 3 containers of juice. When I doubled the recipe, I ended up with 2 containers of soda and 6 containers of juice. Now, if I simplify 2 and 6, they both have a 2 in common, and that reduces down to 1/3. Right? Cool. And then when I tripled the recipe, because I cannot tell you, the place was a madhouse with all those kids in there, but, I love them all. We've got 3 containers of the soda, and then that means we ended up with 9 containers of juice. So every time I look at it, I get 1/3. 2 divided by 2 is 1. 6 divided by 2 is 3. 3 divided by 3, is 1, and 9 divided by 3 is 3. So I get the same ratio. They don't look the same because it's equivalent fractions. All right, so let's go ahead and practice on the next page. Okay, so let me just confess. I took a picture of these examples on my ottoman of my rocking chair that I've had since Tiana was born, and so you see a little bit of the fabric peeking out. Sorry about that. Okay, so here's an example of a ratio table. So a patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours will it take to receive 4 liters of IV fluids? So basically, what I need to do is figure out, what did I do to my initial amount of 1 liter every 8 hours to get to 4 liters? So I'm just going to think about that, and it's like, well, yeah, if I multiply 1 by 4, I'm going to get 4. And you know how we like to treat both parts of ratios the same? Just like we do fractions, we're going to multiply the denominator by 4. So what I get is 32. So I would say, and the reason why I knew it was a multiplication problem is because I watched my numbers increase. So that's a little hint. When numbers increase, so we went from 1 to 4, we're going to multiply to show what happens to the original number in the denominator. Okay, and now they did call this a rate, and I hope you all see why, because 1 represents liters, but 8 represented hours. So it's 2 different labels. Okay, so my conclusion would be it would take 32 hours to receive 4 liters of IV fluids. That's a long time. Ooh, could you imagine sticking that thing in you and waiting for all that juice in the bag to empty? Ooh, no thank you. But hey, if it saves your life, you got to do it. To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Find the amount of sugar needed for 4 cups of cranberries. Okay. Now, I'm going to tell you that there is 3 columns in here. And the reason why we're going to see those 3 columns is going to get revealed in the video you're going to watch on Monday. And what's happening is sometimes our number that we start with can not become the number that we want. So we have to do some other activity in order to get what we want. So today we don't have that problem. Monday I'll show you how to do that. So we look here, and I see the only 2 numbers that I have on the same row are under cranberries. We've got 16 goes to 4. So if you notice, when I go from 16 to 4, ooh, that's super bright. Wow. I think I'm going to change that to a darker one. Sorry about that, guys. Wow. There we go. In order to go from 16 to 4, I'm not going to use multiplication. In fact, I'm going to use the inverse of that. I'm going to use division. So I'm going to say numbers, boy, that looked like an A, didn't that? Numbers decrease. So we go from 16 to 4. That's, let me write that in there. So 16 to 4, that's when we're going to divide. Okay? So let's see, 16 divided by 4 is going to give me 4. So whatever I do to the denominator, I'm going to do to the numerator. So when I divide by 4, 12 divided by 4 is 3. So my conclusion would be 3 cups of sugar are needed for 4 cups of cranberries. Okay? So again, all we're practicing here is the idea of equivalent ratios, but we're creating those equivalent ratios by knowing one piece of the second ratio and doing math to get from that original piece. Like in the top problem, we had the original 1 liter of fluid, and we knew it was going to go to 4 liters of fluid. So to go to that increase, we multiplied by 4. And then with the denominator 8, we would have to do the same math, multiply by 4. And that's where the 32 came from. And then in the bottom example with the 16 cranberries going down to 4, we used division. We divided by 4. So we had to do the same thing to the number on top, the 12. And when we divided 12 by 4, we got the 3. So all we're doing is creating a table where all the ratios have the same value. All right, so Monday we're going to talk more about this. All right, enjoy this.